Imagine a future where the next wave of groundbreaking software startups emerges not from the usual hardware giants, but from the deep research of algorithms. This is exactly the bold vision IBM's Scott Crowder, Vice President of Quantum Adoption, is championing. But here's where it gets controversial. While India stands as IBM's second-largest global community of learners after the US, it surprisingly trails behind when it comes to applied algorithm research, the very area poised to fuel the most transformative innovations. Crowder highlights that IBM is encouraging regional governments to think beyond just acquiring hardware and securing supply chains. Instead, they should focus on cultivating vibrant communities dedicated to algorithm application research. Why? Because this intellectual ecosystem is where tomorrow's software startups will be born, driving significant economic growth. To put it simply, the major beneficiaries of advances in artificial intelligence aren't only the companies building the physical chips like NVIDIA, but also those creating the algorithms and applications that transform technology into real-world solutions. In India, IBM's collaborative efforts have taken a tangible shape through partnerships such as the one with Tata Consultancy Services, TCS, to develop quantum computing capabilities, particularly within Andhra Pradesh's ambitious Quantum Valley Tech Park project in Amaravati. This initiative aims to host the IBM Quantum System 2 installation, featuring a 156-qubit Heron quantum processor, set to be the largest quantum computer in India when completed. Such infrastructure is more than just a hardware milestone. It serves as a central hub, fostering innovation and attracting talent in quantum algorithm development. Moreover, TCS and IBM have signed agreements to provide cloud-based access to these quantum systems for researchers and technologists across India, thereby democratizing access to cutting-edge computing resources. Crowder explains the strategic reasoning behind physically locating such systems in India, even though cloud technology could theoretically minimize the importance of location. Drawing on examples like Japan, where local quantum computing installations helped energize the tech ecosystem, IBM believes that having tangible infrastructure on the ground accelerates excitement, collaboration, and growth within the community. When asked about India's overall quantum computing strategy, Crowder acknowledges that progress has been steady, but emphasizes there is room for more robust investments, particularly on the hardware front. He points out, however, that India can make significant strides in software innovation without requiring massive financial commitments. In a country as vast as India, having in-country infrastructure is justified, but achieving the right balance means complementing hardware investments with a strong focus on developing algorithms and software applications that solve pressing challenges. This perspective challenges conventional priorities that might overly emphasize physical equipment at the expense of nurturing the intellectual groundwork that drives long-term technological leadership. So here's the question to the community. Should India accelerate its hardware capabilities immediately, or focus more on cultivating algorithmic research and software innovation first? Does physical proximity to quantum systems genuinely translate to better ecosystem growth, or will cloud access eventually level the playing field? We invite you to share your thoughts and spark a conversation on what the future of quantum computing and application research should look like in India and globally.